Here we'll do some rational inequality practice. We have 15 over x plus 2 is greater than or equal to 3 over x minus 2. The first thing we'll need to do is find the LCD of these fractions. We can see our first denominator is the binomial x plus 2. We have another fraction in the form of this other binomial x minus 2. Since we have two different binomials, our LCD must be both binomials multiplied together. Therefore, we'll use x plus 2 times x minus 2 as our LCD. After that, we will adjust both fractions to give them the LCD by multiplying by something on the top and bottom. Our first fraction already has x plus 2. That's in the LCD. However, it's missing x minus 2. We'll make a note that we need x minus 2 on the top and bottom here. So we'll rewrite our fraction. We'll have 15 over x plus 2. We'll place that x plus 2 in parentheses, and then multiply on top and bottom by x minus 2. Now we look to the other fraction. The other fraction has x minus 2, but it is missing x plus 2. So we'll make a note that we need x plus 2 here. We'll write down our old fraction, 3 over x minus 2, put that x minus 2 in parentheses, and multiply on the top and bottom by x plus 2. Then we'll place our greater than or equal to sign in the middle. Now that our fractions both have the LCD, we will need to simplify the numerators and move the fractions to the same side. Let's first begin by moving the fractions to the same side. Therefore, the fraction on the right, this 3 times x plus 2 over x minus 2 times x plus 2, we will move to the other side, over here to the left, and we'll change the sign to negative. Therefore, we now have 15 times x minus 2 minus 3 times x plus 2. It will all be over the LCD, x plus 2 times x minus 2. We don't need to write it twice, we'll just combine these fractions together. We'll still put the greater than or equal to symbol, but now we'll just have 0 on the right. Now we simplify the numerator. We'll have 15 times x and 15 times negative 2. 15 times x is 15x, and 15 times negative 2 is negative 30. Then we'll take negative 3 times x and negative 3 times positive 2. Negative 3 times x gives negative 3x, and negative 3 times positive 2 gives negative 6. All of this will still be over our LCD. It's still x plus 2 times x minus 2. Now we can combine some of our like terms. 15x minus 3x gives 12x, and negative 30 minus 6 will give negative 36. We'll still write this over the LCD, and we will still say this is greater than or equal to 0. Now that we've simplified our fraction, let's find the zeros and the asymptotes. We'll begin by finding the zeros. To find the zeros of a rational inequality, we will set the top equal to 0. Therefore, we'll take 12x minus 36 and say it equals 0. We can add 36 to both sides, giving us 12x equals 36. Then if we divide both sides by 12, we'll get x by itself. If we take 36 divided by 12, we'll get 3. Therefore, our first 0 is x equals 3. Now to find the asymptotes of the rational inequality, we'll set the bottom equal to 0. Since we have two separate binomials in the bottom, we will set each of them equal to 0. If we solve x plus 2 equals 0, we'll just subtract 2 from both sides and get x equals negative 2. If we do the same to x minus 2, we'll add 2 to both sides and get x equals positive 2. So your asymptotes will be x equals negative 2 and x equals 2. Now that we have our asymptotes and zeros, we'll place everything on a number line. Let's mark the places on the number line where we find zeros and asymptotes. Our 0 is at positive 3, and our asymptotes are at negative 2 and positive 2. We'll also write negative infinity and positive infinity on our number line. Now asymptotes will always be open circles. Therefore, the position at negative 2 and positive 2 will be open. Our zeros can be open or closed, but that depends on the inequality symbol in the original inequality. Greater than or equal to, or less than or equal to, will be treated as closed, but strictly greater or strictly less will be open. Since we have greater than or equal to, our 0, located at x equals 3, will be closed. Based on this, we can split the number line into pieces. We'll label the regions A, B, C, and D. Now we'll need to select x's within each region and try to find if our inequality turns out greater than 0 or less than 0. Keeping in mind that our symbol was greater than or equal to, which means our condition for this inequality is that we would like it to be positive. We'll now visit each region and find out which regions are positive. We'll begin with region A, and we'll pick an x that is less than negative 2, and we'll land in region A. Let's try x equals negative 3. On top, we'll have 12 times negative 3 minus 36. On bottom, we'll have negative 3 plus 2 times negative 3 minus 2. 12 times negative 3 will give us negative 36. If we subtract another 36, we'll get negative 72. We don't really care that much about the number, though. We care that it's negative. On the bottom, negative 3 plus 2 will give us negative 1, and negative 3 minus 2 will give us negative 5. Therefore, on the bottom, we have a negative times a negative. If we multiply those two together, we'll get a positive answer. Therefore, our final answer will be a negative over a positive, which will return a negative answer, regardless of what the numbers are. We will label region A as negative, and note that our condition was positive. Therefore, region A is not part of the answer. Next, we move to region B and select an x between negative 2 and positive 2. Let's use 0, because the math is fairly simple for that. We'll have 12 times 0 minus 36 over 0 plus 2 times 0 minus 2. Since 12 times 0 is 0, we'll just have negative 36 on top, and on the bottom we'll have 2 times negative 2. So on top we have a negative, and on the bottom, if we take 2 times negative 2, we get another negative. A negative divided by a negative returns a positive answer. Since region B is positive, it will be part of our final answer. Next, we'll move on to region C, and we'll pick an x in between 2 and 3. Let's try 2.5. We take 12 times 2.5, subtract 36, over 2.5 plus 2 times 2.5 minus 2. On top, 12 times 2.5 will give us 30, and we'll take 30 minus 36. On bottom, we'll take 2.5 plus 2, which is 4.5, multiply by 2.5 minus 2, which is 0.5. On top, 30 minus 36 will give us negative 6, which is a negative answer. On bottom, 4.5 times 0.5, they're both positive numbers, so we'll get a positive, and a negative over a positive returns a negative answer. Therefore, region C is negative. That does not fit our condition, so region C will not be part of the answer. Finally, we'll move to region D. Let's let x equal something greater than 3, and we'll try 4 here. We'll take 12 times 4, minus 36, over 4 plus 2 times 4 minus 2. 12 times 4 is 48, minus 36 will give 12. 4 plus 2 is 6, times 4 minus 2, which is 2. So notice we have a positive on top, and 6 times 2 is still positive on bottom. So region D returns positive, and that will be part of the answer because that matches the condition. Therefore, our solution set will have B and D. For region B, we'll take negative 2, comma 2, and since both sides of B are open, we'll place parentheses on either side. Then we say union, and then region D goes from 3 to infinity. We'll put a parentheses around the infinity and a square bracket around the 3 to show that it's closed. This will be our solution set for the inequality.